All right, thank you so much for joining us today. And this is review exam for UIC students, exam 2. But if you are not UIC students, this is also a great video for you if you are taking a calculus class. So what I'm going to do here is I have 7 questions that I want us to go through, and I will show you the tips and the strategies when you see the question, the things that you just need to do, and then how you can approach each questions. So let's jump right in. So the first question is asking us to write down the limit definition of derivative of a function. So this is pretty straightforward. We should be able to know how to write the formula down. So let's do that. F prime is equal to limit as h is approaching 0, f of x plus h minus f of x all divided by h. So this is basically the limit definition of derivative, right? So when you start derivative, or if we're about to start derivative, this is the first thing that they are going to teach you, limit definition, and you are going to use this one to solve some questions. But we know that this is not basically, the right tool to solve a lot of derivative questions, because some of them are so complicated that we cannot use this to solve it. So most of the time, all the questions that we use this to solve is kind of very simple for us to simplify to get the right answer, right? Now let's look at B. B is asking us to use the definition that we gave to find this. Now the trick here, or the tip here, is now anytime you are using the limit definition formula to find the derivative, one thing that I'm going to do here first is you will see that I'm going to quickly find f prime of this function, which is going to give me minus 4x using the power rule. So this is basically going to guide me throughout my work that I'm going to do here. I know that when I use this limit definition here, I should be able to get this right here. So that's basically how it is. But if I just leave this one as my answer here, I'm going to score 0, because that's not the right thing to do. So no, you don't do that. This is to guide you to know that, okay, this is what I need to get at the end of the day. So now let's just start. So since we have the definition here, what do we need? We need f of x, which is already given. So let's write it down. F of x is equal to 3 minus 2x squared. What do we need again? We need f of x plus h. Now, for me to get f of x plus h, what I do is I try to make sure that I put all my x into parentheses, because I can see that this x is into parentheses. So I'm going to change this one to 3 minus 2x squared. So you see that this is into parentheses, this is also into parentheses. Now the one in the parentheses here is x plus h. So I'm going to change all the one in the parentheses to x plus h. So this is what I'm going to get. I'm going to have 3 minus 2, then I'm going to have x plus h squared. So you see that this is in the parentheses, this is also in the parentheses, x plus h, x plus h. This is x, and this is also x. So this is how you can also find x plus h. Because if you don't get x plus h right, then everything that you are going to do is going to be wrong. So that's basically the idea. So it's good for you to know how to get your x plus h. Now what I'm going to do here is I'm going to expand this. Minus 2, I can write this as x plus h, x plus h. This is the same as 3 minus 2. Now let's try and expand this. So x squared plus 2xh plus h squared. So when you are taking calculus, expansion, factorization is also very important in this course. So let's try and then see what we can get from here. Now I can write this one as 3 minus 2x squared minus 4xh plus 2, no, supposed to be minus 2h squared. So I just distributed my minus 2 throughout and get minus 2, minus 4, and a minus 2 here. So can I do any simplification here? No, I cannot do any simplification here. Now this is what I do. After I'm done finding my f of x plus h, I try to find for f of x plus h minus f of x first before I apply the formula here. So let's do that. So let me shift this one to the left side small. Okay. Then let me shift this one to this one small. So right now I need f of x plus h minus f of x. So this here is equal to what is here. So I'm going to have 3 minus 2x squared minus 4xh minus 2h squared minus my f of x. Now don't forget, anytime I'm taking the minus, I need to make use of the parentheses. So I'm going to put this one into parentheses and have 3 minus 2x squared. Now let's try and simplify this. This is the same as 3 minus 2x squared minus 4xh minus 2h squared. Then when I distribute the minus, I'm going to have minus 3 plus 2x squared. So what is going to happen here? This will cancel this and this will cancel this. So the strategy here is anytime you are dealing with limit definition and you take f of x from f of x plus h and you simplify, your final results should be in terms of h. So if you simplify and the function, one of the function is not in terms of h, it means I need to check your simplification again. So assuming that I had, like, let me say x plus x, this x here is not with h, so it means that my simplification is wrong, because I should be able to get all the terms left to be left with h, or should be going with h. So what I can do here is, since all the term is with h, I can factor h out and have minus 4x minus 2h. So this is very simple. So I was able to find this, which is equal to this. So now I can now use the formula here. So now let's find for f prime. Let's find for f prime. So now f prime of x is equal to limit as h is approaching 0. Now I don't need to write this again because this is equal to what is here, which we found it here, right? So I'm just going to use that and write h minus 4x minus 2h divided by h. So divided by h here. So I did that so that I can cancel this h. So the only problem here was the h, because when you plug in h, the denominator becomes 0 and we have issue. So now this is now equal to limit h is approaching 0 minus 4x minus 2h. Then I'm going to set h to be equal to 0. So this is going to give us minus 4x. Let me move this one to this side small. So minus 4x minus 2 times 0. And this is going to give us minus 4. This is going to give us minus 4x. So this is our f prime of x. So let's go and check it out. We saw that, okay, when we use power rule to differentiate this, we had minus 4x. So getting minus 4x here is correct. All right. Let's look at question 2. Now, question 2 is saying that the height in feet of a tennis ball thrown off the roof of the tower at Student Center East is given by this, where t is time in seconds. We want to find the instantaneous velocity of the ball after 1 second. So after 1 second means that we want to find the instantaneous velocity at t is equal to 1. But one thing that you need to remember here is, when we started class, we started with velocity and we're talking about instantaneous rate of change. And you need to know that instantaneous rate of change that we are talking about here is basically the f prime at 1, right? So that's basically what we need. So when you find the derivative and we plug in 1, we get the instantaneous velocity at time t is equal to 1. So that's basically what we just need to do here. Because remember that instantaneous rate of change is basically when something is approaching something, we are looking at what the actual value is going to be approaching. So for example, using the limit definition here, this is actually, let me say, the instantaneous rate of change, because we are looking at when h is approaching 0, then what happens to the function. But here we can just differentiate it straight and get the results here. So now let's see what we can get here. So now we need f prime. So f prime of t is equal to, so let's differentiate this. We are going to have minus 30 t minus 5. So I use the power rule to differentiate this. Let me write the t again. So we had f of t to be equal to minus 15t squared minus 5t plus 300. So we are differentiating this with respect to t. So power rule, 2 drops down to multiply this, giving us 30. Subtract 1, and this one will be 1. And when I differentiate t, I'm going to get 1 because the power is 1. Drop 1 to multiply this, get this. 1 minus 1 is 0. T to the power 0. Since t is not 0, it's going to give us 1. And when I differentiate the constant, it gets 0. So all I need to do here is now plug in when t is equal to 1. And I'm going to have minus 30 times 1 minus 5. And this is minus 30 minus 5. And this is going to give us minus 35. Now let's add the unit to it. So this one should be feet per second. Yes. So we are talking about feet and we are talking about seconds here. So feet per second. That's what you are going to get from question 2. Now let's look at question 3. Question 3 is interesting. It's all about taking derivatives. So I'll show you the tricks that you need to know here. So the first thing that we need to do here is, now some of the functions we need to simplify before we differentiate. For example, this. So this function here is the same as 2x to the power 4 minus, now 2 divided by x squared is the same as 2 times 1 over x squared, and this is the same as 2x to the power minus 2. We need to write it this way so that we can use the power rule to solve this. So this is the same as 2x to the power minus 2 minus e 2x plus this. So what I did here was not the derivative. I was just basically simplifying the function so that now I can take the derivative. So now let's find for f prime of x. So let's use the power rule here. This is going to give us 8x to the power 3 minus 2 times minus 2x to the power minus 3. Then, so what did I do here? 4 drops down, multiply this, subtract 1. I have my 2 here. I drop the minus 2, which is here, then I subtract 1. So I'm going to get this. Then minus, now this is an exponential function. So exponential function, it says that if I have e to the power gen of x, then this is equal to gen prime times that. So where is the gen prime? Gen prime is what is here. So I need to differentiate what is here and use to multiply the function. So I'm going to differentiate 2x. And when I differentiate 2x, I'm going to get 1. Sorry, I'm going to get 2. So this is going to be 2e to the power 2x. Then this is constant. So when I differentiate it, I'm going to get it to be 0. So this is what I'm going to get at the end of the day. Okay. So this is the derivative that we are going to get from here. We can simplify this once more. Even though the question is saying that don't simplify, but we can make this one plus 4 x to the power minus 3 minus 2e to the power 2x. So this is what we are going to get for the first one. Now let's look at b. Okay, so b, I'm going to use the product rule. So I'm going to say that I have a and b, and then I'm going to assign a to x to the power 3, and then I'm going to assign b to be cosine of x, sorry, secant of x. So I need a prime. So what is a prime? Use the power rule here. We are going to have 3x squared. What is b prime? This, when I differentiate secant, what am I going to get? Oh, I'm going to get secant x tangent x. So now let's apply the power rule, sorry, the product rule here. A times b prime and b times a prime. So the power rule says that, sorry, how am I saying power rule? The product rule says that if I have f of x which is equal to ab, then this is equal to ab plus ab, right? So what I'm going to do here is, if I put the prime on a, then I need to put the prime on b here. If I put the prime on b here, then I need to put the prime on a here. So any of them works because addition is commutative. So if I want to use prime here, then I'll put the prime on this one, and I'm done. So let's do that. A prime times b, so this time this is going to give us 3x squared secant of x plus a times b prime. So a times b prime is going to give us x to the power 3 secant x tangent x. So this is super simple here. Now let's look at c. So C, we are going to use the change rule, right? So we have different ways of doing this. So you can think of like you having a function f of x, which is equal to gen, and you have h of x. So the chain rule says that f prime of x should be gen prime. You differentiate the out function. You maintain the inside function without touching it. Then now you multiply it by when you differentiate the in function. So that's basically what you are going to do here. So here, f prime of x will be equal to, now I need to differentiate the out function, which is tan. So when I differentiate tan, I'm going to get secant squared. So secant squared, I maintain the in function, then now times taking derivative of the out function. You can just write it straight. I just want to show you how the thing is going. That's the reason why I didn't say that times 2x, and I'm saying that we need to differentiate what is inside the parenthesis. So this is now going to give us secant squared. Then when I differentiate x squared plus 1, I'm going to have times 2x. Now I love putting this into parentheses because, so what the advice I'm giving you is anytime you use something like dot, make sure that the function that you are going to write, you put it in what? Parentheses. It's better because when the function is 2, and so for example, let's assume that this one was, let's say, 2x plus 1, and you just use the dot here. This dot here means that we are just multiplying this to this without multiplying this to the 1. So anytime you use a dot, make sure you put it in what? Parentheses, which is very helpful, super helpful. Okay, so this is what you are going to get after differentiating this, right? Some people too can say that let me let u to be equal to x squared plus 1 so that I can have f of x to be equal to tan u. So this one, when you differentiate it, you are going to have f prime of x is equal to secant squared u times u prime. So what is u prime here? U prime here is equal to 2x, and you just do substitution, and secant squared u is x squared plus 1, and u prime is 2x. So it's the same thing. The way you understand it, the idea is that you have gotten it because we have different method of doing change rule. So any of them works out. Make sure you pick the one that you are comfortable with, then you go with it. Now let's look at D. So now D, we are going to use the quotient rule. So one thing that you need to know is anytime you see the question, now you ask yourself, which rule are you going to use, right? It's kind of very important to know that as soon as you identify the rule, then you are almost there. So I know that this one I'm going to use the quotient rule. So I'm going to say that let the top be u and then the down be v. So it means that my u is equal to x squared minus 4 and my v is equal to 3x plus 2. So I need u prime, I need v prime. So what is u prime? Using the power rule here, I'm going to have 2x because when I differentiate minus 4 is constant, so we are going to get 0. And when I differentiate 3x, I'm going to get 3 because when I differentiate 2, I'm going to get 0. So the question is, what is the quotient rule? So me using u over v, f prime of x will be equal to v u prime minus u v prime divided by v squared, right? So all I just need to do here is now do substitution because I know the formula here. So v is here, u prime is also here. So I'm going to have 3x plus 2 times 2x, then minus u is x squared minus 4 times 3 divided by 3x plus 2 all squared. Now don't forget this formula here, some people too like to write it this way. Instead of Vn first, they try to write it f prime of x is equal to u prime v minus v prime u divided by v squared. Any of them is all right. But the idea is that you should maintain the first one that you are doing here should be then not differentiated. So you can just, multiplication is commutative, so you can just do this or do this, and then you are also getting it right from there. All right, let's look at the next question here. All right, so I think this one we are lucky enough, and then they've drawn this one for us already, so we don't have much to do, right? So we have the 8 feet, which is already given here, and the rope is being used to pull in. So this one, this pull in here is a strange word, right? This pull in here is a very strange word. So pull in here, you need to think about negative something, right? Pull in. So now let's go ahead and then let's see what we can do here. So the first question is, suppose that x is the horizontal distance, which is already labeled, from the dock to the boat, right? And r is the length of the rope, okay? So this is the length of the rope. Write an equation relating x and r. So this one, we are going to use the Pythagoras theorem. So, this is the long distance. So when you square this plus square this, it should be equal to when you square this. So this is very simple for us to write. So this is just going to be x squared plus 8 squared is equal to r squared, right? If you want to simplify this, then this is x squared plus 8 squared is 64, and then it's equal to r squared. So this will be the equation that we are going to get. Now the question is, if the rope is being pulled in, so as I said, the pulled in here is a very strange word, so we need to think about negative. At a rate of 1 foot per second. Now, don't forget, we are talking about rope, right? And then the rope is the r. So it means that since we are talking about rate here, and remember, related rate, we go with respect to time. So it means that the r over the t is equal to -1, because we have the rate. So we have the rate, which is d over the t, and it's going with the rope. And then we have the pull in. So we are going to have it to be negative here. And then the question is, what is the speed of the boat when the boat is 6 feet horizontally from the dock? So that's what we are looking for. We are looking for the x over the t, which we don't know. And then they've given us that x is equal to 6 when we are 6 feet from the dock. So that's basically the information that we have here. So it means that we are going to use the equation that we found here, because that's what is going to help us to work on the rest. So let me write the equation down, then we work on it. So x squared plus 64 is equal to r squared. So we need to differentiate both sides with respect to time. So that's basically what we are going to do. So let's go through the process. Differentiate x squared with respect to time is going to give us 2x dx over the t. 64 is constant, so it's going to be just 0. Then differentiate r with respect to t is going to give us 2r dr over the t. We are looking for dx over the t, so I can divide through by 2x, and I'm going to have dx over the t to be equal to 2r over 2x dr over the t, and then 2 can cancel out and have r over x dr over the t. Now let's see, we have x, we have the r over the t, but we don't have r. So how can we find for r? We can use the Pythagoras theorem here, because since we know x, then we can find for r. So let's do that. Now r is going to be, x is 6, so I'm going to have 6 squared plus 64 is equal to r squared, coming from here, whence x is equal to 6. So now 6 squared is 36 plus 64 is equal to r squared, and this is equal to 100 is equal to r squared. Then when I take the square root of 100, I'm going to have 10. So now I know r, I know x, I know the r over the t. So it means that the x over the t will be equal to, I'm here, so r is 10, s is 6, and the r over the t is minus 1. So what are we going to get here? We can cancel this one 3 and cancel this one 5 by 2, multiply by minus, and we are going to have minus 5 divided by 3 feet per second. Good. So the only thing that, I think this question is easy. The only thing that was, we need to pay attention to was the pull in. Because if you don't see the pull in, you are going to just make sure that this is 1 and your answer is going to be positive instead of it being negative. So that's basically what is going to happen here. So here we are saying that it's minus because the rope is being pulled in. So that's the reason why it's negative from there. Yeah, so pay attention from there. All right, let's look at 5. 5. Let f of x be differentiable function, and then f of 2 is this, and then f prime is this. What is the equation of the tangent line? So first, we need to record the equation of the tangent line. So what's the equation of the tangent line? We know the equation of the tangent line is y minus f of x, okay, let me call it x1, is equal to f prime of x1, x minus x1. So if you remember, I said that anytime you are within the equation of the tangent, the point given to you is x1 and y1. But when you are finding the slope, the point given to you is x and y. So since we are with the equation of the tangent, the point given to us here, they are saying that is x is equal to 2. This is actually x1 because we are in this equation. So let's see what happens here when I plug in, when I set x to be equal to x1 to be equal to 2. I'm going to have y minus f of 2 is equal to f prime of 2 x minus 2. Then when you look at the information given to us, we will see that f of 2 is 3, then f prime of 2 is 4 from here. So it means that this is going to give us y minus 3 is equal to minus 4x minus 2. And we have it here. So pay attention. I wrote it this way. Remember, equation of the tangent 2 can be written as y minus y1 equals dy over dx, x minus x1, depending on what is given to us. So the function was in terms of f of x, so it's good for you to write it this way, knowing that y1 is the same as f of x1 and dy over dx is also the same as f prime of x1. So that's basically what you need to pay attention here. Good. Now let's look at question B. Now let f of s be the temperature of the piece of chicken placed in 5 degrees Celsius freezed after T minutes. So we have f of 50 to be this, and then f prime of 50 to be this. What is a good estimation for the temperature of the chicken? 52 minutes. Okay, so what basically we want to do is we want to find the approximation. So here, the best thing to do here is to, do linear approximation. Now, linear approximation, I'm going to use the same thing here, but instead of this, I'm going to use f of x. So it's the same thing that we are going to use here. So let's look at what I'm going to do here. So I'm going to write this one like this. So the linear approximation here is going to be, let me say, y is equal to, but let me write it this way so that you understand what I'm doing here. So this is going to be y minus f of x1 is equal to f prime of x1 again, then x minus x1. But linear approximation is going to be y is equal to f of x1 plus f prime of x1 then x minus x1. I hope you can see it well because the space is too small. Okay, so let me put this one here and put this one here. So this is what I've done. But what you just need to know here is I'm going to change this y here to f of x because we are dealing with linear approximation. So if this goes with x1, then this x here should be going with f of x. So that's what you need to pay attention here. So let's see how we can write this one. This one can be written as f of x, which is equal to f x1 plus f prime of x1 x minus x1. Now we can see that we want to find approximation at 52. So our x is 52. So it means that we are going to have f of 52, which is equal to, now what are we going to do here? We are going to set our x1 to be 50 because we have this one here. So we have 52 and we have 50. So we are setting our x1 to be 50. So this is going to give us f of 50 because we are doing approximation plus f prime of 50, then 52 minus 50. So here what I'm doing here is x is equal to 52 and then x1 is equal to 50. So that's basically what I'm doing here to make sure that I form this equation. Now right after forming this equation, we know that f of 50 is given to us as 10, and then f prime of 50 is given to us as minus 0.5, and then when I subtract 50 from 52, I'm going to have 2. So now let's try and simplify this. This is the same as 10 minus 0.5 is half. So half times 2 is going to give us 1, and this is supposed to be giving us 9. Do we have 9? Yes, we have 9 here. So this will be the best option for us to choose. So you saw that I used the same idea for equation of the tangent line, but the only thing that I was changing was my y. My y is also the same as f of x. So don't forget that y is also the same as f of x. So if y is the same as f of x, then I can change this y here to f of x and then have it this way. Then since I'm doing approximation, my x is equal to 52, and then my x1 is equal to 50, which was here, and then I just do it straight. Now, if you don't want to trouble yourself and then just know whatever you want to do, then you just write. But I just wanted to let you know how the process came about. So you can also learn this formula here, approximation, f of x instead of y, then you go through the process. All right, let's look at C. Let's look at C. Now, suppose f of x is continuous on the interval 1, 5, and then f of 1 is 7, and then f of 5 is 10. For which of the following values of y is there guaranteed to be a number C between... Okay, so this is basically the intermediate value theorem. So as soon as I find out that this is the intermediate value theorem, now what is the intermediate value theorem? Remember, I can choose C here. C is between 1 and 5. So this is the best way to see this. X and 5. So this my C here is between 1 and 5. So the intermediate value theorem is saying that if I have a C in between 1 and 5, then when I plug in this 1 inside the function and I plug in this 5 inside the function again, their value or their outcome is also going to be, this one will be greater than this and this one will be less than that. So here what I'm going to do is I want to show you the shortcut. I'm just going to pick f on the function and have f of 1 less than f of c less than f of 5. So this is the intermediate value theorem. So if c is between 1 and 5, then when I plug in 1 inside the function, so and 5 inside the function and c inside the function, they are going to hold, the inequality is going to hold. f of c will still lie between f of 1 and then f of 5. But the question is, what is f of 1? F of 1 is 7. Then what is f of 5? F of 5 is 10, which is given in the question here. So the question is, now looking at the option, because here we don't have information for us to find for f of c. We don't even know c. So the idea is that we need to pick any value from the option, which is between 7 and 10. And the only value which is between 7 and 10 in this question is 8. So that's basically what you can do to get your results here. So y should be 8, right? So if y is 8, don't forget y is the same as f of c, which is 8. So this is how you can form your intermediate value theorem. Now let's look at D. So D is basically squeeze theorem. So we have square root of 5 plus cos x less than or equal to f of x less than or equal to 3x minus pi squared plus 2. Now we need limit as x is approaching pi of f of x. Now we have f of x here. So the only thing that is missing here is the limit as x is approaching pi. So I'm going to take limit as x is approaching pi on this, and that we solve. So let's do that. Limit as x is approaching pi of square root of 5 plus cos x is less than or equal to limit as x is approaching pi of f of x less than or equal to limit as x is approaching pi of 3x minus pi all squared plus 2 in parentheses. So squeeze theorem, if we evaluate this and it's the same as this, then that value is equal to what is here. So now let's check it out and see what we are going to get from here. Now, this is like, not a function that we need to think of, doing simplification. So let's do direct substitution first and let's see what is going to happen. Set s to be equal to pi. So it means that here is going to be 5 plus cos pi less than or equal to everything in between here, less than or equal to set x to pi and have 3 pi minus pi squared plus 2. So let's see what is going to happen here. Now, what is cos pi? What is cos pi? So looking at the graph, when you talk about cos pi is -1, right? So cos pi is -1. So it means that this is going to give us square root of 5 minus 1 less than or equal to limit x is approaching pi of f of x less than or equal to, now here pi minus pi will be 0, so everything here will be 0, and this one will be equal to 2. Now this is the same as square root of 4, and square root of 4 is 2. So we can say that the left is 2, the right is 2. It means that the limit here exists and is equal to 2. So we are going to choose this one here. Very simple here. Okay, let's finish it up with this last two questions. So yeah, they've given us f of x, and then we want to sketch f prime of x. So this is like me giving you f of x is equal to x squared, and then asking you to sketch the graph for f prime. So for me to get f prime, then I need to differentiate the function to have 2x, and then what? Plot or sketch the graph for this. So I know that this is this, so it means that now this is becoming a linear. Now, one thing that you need to know here is if the function is quadratic, then when I differentiate it, it becomes linear. When the function is cubic, then when I differentiate it, it becomes what? Quadratic. So if the function is having one either minimum or maximum, then it means that when you differentiate it, you are going to get a linear function. So that's basically what is happening here. So looking at this function here, I can see that when I differentiate this function here, it's going to be linear. But let's just study this graph and see what is happening here. I can see that I have one point here. Let me call it -1, -1. I have another point here. I have 1 and 0 and 1. I have another point here. I call it 1 and 3. I have another point here, -2 and 0. I have a point here which is -3 and 1. I have another point here which is -4 and 2. So since I have this line, I have some point on it. This one too, I have some point on it. Remember, we are looking for f prime. So since this is a linear and this one too is a linear function here combined, then what I can do is I can find the slope of this line and find the slope of this line. But at the minimum, we have x is equal to -1. So it means that we have x is equal to -1. So what I'm going to do is, if I put a line in between this, s is equal to -1 here, then I'm going to have the right side, I'm going to have the left side. So let's now consider them. So on the left side, when x is less than -1, then what can we do? We can find the slope for this. So let's find the slope. Slope is the same as f prime, right? So let's find the slope of that. So slope of, let me see, okay. Let me just use slope here. Slope is change in y over change in x. So let's do that. Let's pick 2 points. So I can pick this point, -2 and 0, and -3 and 1. So let's find the slope. I'm going to have 1 minus 0 divided by -3 minus -2. So 1 minus 0 and then -3 minus 2. So this is going to give us 1 divided by -3 plus 2, and this is 1 divided by -1, and this is going to give us -1. So the slope for the left side is -1. So we can say that f prime of x is equal to -1. Now we can also look at when x is greater than -1. So when x is greater than -1, we are looking at this side. So we can pick these 2 points to find the slope. So let's find the slope for this. So the slope will be equal to, the point is 0, 1, 1, 3. So change is going to be 3 minus 1 divided by 0 minus 1. Let me see. 3 minus 1. Okay, this one should be 1 minus 0. So I'm going to have 1 minus 0. So this is going to give us 2 divided by 1, and this is 2. So the slope is 2. So now let's come to the f prime graph here. Now remember, we have this kind of like a discontinuity at s is equal to -1 here. So all the lines should be here. So now I have f prime on the left to be -1. So I should be on this and have, let me say, -1 here open, because it's kind of jumped. And then on the right, I have 2. So on the right, I have 2 here. Now, what is happening? Look at here. F prime of x is equal to -1. We are going to the left. Don't forget it's less than -1. Now, when I plug in -2 here, I'm still going to get -1 because this is constant. So since this one is constant, any value that you are going to put in this function, you're going to get -1. So it means that this is going to be like something like this, just moving. This is just going to just move along the one graph and going like this because it's constant. We can see that this one too is constant too. So no matter the value of x that you are going to pick for this, when you plug it in, it's also going to give us 2. So this is also going to go this way like this. So this will be the graph for our function that we have from here. So when you go and it's linear function like this, sometimes it's kind of easy, but when it's not linear, then we have different strategies that we need to use to also solve the function. Now let's do the last one, and then we look at spring 2025 exam questions too as well. So now this one, we want to find the slope of the tangent, just the slope of the tangent. So let's just go through quick. So we have sine y, which is equal to x squared y plus 5x. So for us to find the slope of the tangent, remember, slope of the tangent, we differentiate the function with respect to x unless otherwise stated, right? So what we just need to do is we need to differentiate the left with respect to x and then the right with respect to x. Now, sometimes you try to do everything in mind and you get it wrong. So I advise you, if you are not very good to do things in mind, then write them down. I'm going to write this one down. Now I'm thinking of sine x as this, so that I can think of the chain rule because I'm differentiating the function with respect to x. And when I differentiate x, what am I going to get? Sorry, when I differentiate sine, we know that we are going to get cos. So it means that this is going to give us cos y. But using the chain rule, when we are done, we need to differentiate what is inside the parentheses here. So when I differentiate that, I'm going to have this one with dy over dx or y prime. So that's basically what you need to know. So anytime you are dealing with implicit differentiation and you are differentiating with respect to x, there is one thing that you can have it in mind. Anytime you are differentiating a function and the function is in terms of y, when you are done, you multiply it by dy over dx because of the chain rule. Now let's go here. Now this one, I have two functions, x and y. So I want to use the product rule. So I'm going to assign a to x squared. You can do it in your mind, but if you are somebody who is not good, you can just do what I'm doing here and then b to be y. So what is a prime? A prime is going to give us 2x. And what is b prime? So b prime, I have y, so it's just going to give us y prime, which is the same as dy over dx because I'm using dy over dx here. So I want to be consistent. So it means that this is going to give us product rule, multiply this by this and this by that. So I'm going to have 2xy plus x squared dy over dx. So what I've done here is just for only this. Now I need to differentiate 5x. When I differentiate 5x with respect to x, I'm just going to have 5. So this is what I've gotten now. Now this one, we don't need to do the hard work of simplifying to get dy over dx. Since we have the point, we can just plug in the point first and then some of the terms will just go away so that it becomes very simple for us to simplify. So don't forget, I said anytime you are finding the slope or you are finding dy over dx, this point here is your x and this point here is your y. It becomes x1, y1 when you are dealing with the equation of the tangent itself. So since we are in the slope, this is x1, sorry, this is y and x. So y is pi, so cos pi dy over dx is equal to x is 0, y is pi, plus x is 0, dy over dx plus 5. So you see how beautiful it is when you do the substitution. Some of the terms are going to be 0. So this is going to be 0, this thing too is going to be 0. What is cos pi? Cos pi is -1. So this is going to give us minus dy over dx is equal to just 5. 0 plus 0 plus 5. So this is kind of beautiful. So dy over dx is equal to 5. Let me put the minus here, and then this implies that dy over dx is equal to -5. So the question was asking us to calculate the slope of the tangent line. So this one, we don't need to find the equation of the tangent. But let's assume that the question is asking us for equation of the tangent, right? Then after we are done calculating for the slope, we know that this should be y minus y1 is equal to dy over dx, x minus x1. So I said anytime I'm inside the equation of the tangent, now this point here now changes to x1, y1. So this point 0 and pi here, now this is x1, this is my y1. So this is going to give us y minus pi is equal to -5 times this minus 0. And we can just write this one as 5 minus y minus pi is equal to -5x and y is equal to minus 5x plus pi. This is in the form of the slope intersection. So that is basically what I have for you here. So in the next video, we are going to talk about spring 2024. This is fall 2024. So we are going to talk about spring 2024. So see you in the next video.